Hey everyone, and welcome. Today we're going to peel back a layer of the internet and look at something that's absolutely critical, but most of us never even see it. We're talking about load balancers. Let's dig into how these unseen traffic cops keep our entire online world from grinding to a halt.
You know the feeling, right? You're trying to grab those concert tickets the second they drop, or you're on a site during a massive Black Friday sale, and boom, the whole thing just dies. It's so frustrating. But what's actually happening behind the curtain?
Well, it's basically a digital traffic jam. It's not that the website itself, broke, it's that it got completely overwhelmed by a huge wave of people all trying to get in at the same time. And this is the exact problem load balancers were born to solve.
So first up, let's really get into what's going on under the hood when a popular website just hits a wall because there's nothing in place to manage that flood of visitors.
See, without a load balancer, you hit some major roadblocks. First off, if your one single server goes down, that's it. Your entire website is offline. That's what we call a single point of failure. Even if it stays online, it can get totally overloaded, which means everything slows to a crawl or it just crashes. And here's the kicker. You can't just throw more servers at the problem, because without a traffic manager, all the requests are still trying to cram through that one original front door.
Okay, so enough about the problem. It's time to talk about the solution to all this digital gridlock. Let's meet the hero of our story, the load balancer.
At its heart, a load balancer is really just a dispatcher. It sits out in front of all your servers, and its only job is to take all the incoming traffic and spread it out evenly across the whole group. This way, no single server gets buried in work.
And honestly, this traffic cop analogy, it's perfect. The load balancer literally looks at all the incoming cars, or, requests, and points each one to the best lane to keep everything flowing smoothly and prevent a total pileup.
So how does this traffic cop do its job?
Well, it follows this really simple but brilliant four-step process. First, it intercepts every single request that comes in. Next, it's constantly running these little health checks on all the servers to see who's online and feeling good. Based on that info, it intelligently sends the request to the best server for the job. And here's the really clever part. If one of the servers suddenly fails, the load balancer sees it instantly and stops sending traffic there, rerouting everyone to the servers that are still healthy.
Now, not all load balancers make decisions the same way. They pretty much fall into two main camps. You've got your static balancers, which just follow a fixed, predictable rulebook, no questions asked. And then you have dynamic balancers, which are way more adaptive. They're constantly gathering real-time data on how busy each server is before they decide where to send the next request.
All right, let's start with the static methods. These are all about being straightforward and predictable. They just follow the preset playbook.
The most basic one of all is called round robin. And seriously, it's as simple as it sounds. It sends the first request to server 1, the second to server 2, the third to server 3, and then it just starts the cycle right over again. Simple, clean, and perfect for something like a news website, where every page request is more or less the same.
The best thing about round robin is that it's just incredibly simple to set up. But that simplicity is also its biggest weakness. It just assumes every server is identical. It doesn't care if one is a brand new supercomputer and another is an older, weaker machine. They both get the same amount of traffic, which means your powerful servers might be sitting around bored, while the weaker ones are struggling to keep up. So, how do you fix that problem? Well, that's where weighted round robin comes in. It's a simple but really effective upgrade. You just assign a weight or a score to each server based on how powerful it is. That way, your beefier machines get a bigger slice of the traffic pie. It's a much smarter way to go if your servers aren't all the same. Okay, before we go any further, we've got to talk about a really crucial idea: session persistence. Some people call it stickiness. Just imagine, you're shopping online and you add a few things to your cart. If every time you clicked a link, the website sent you to a brand new server, that new server would have no idea what's in your cart. So for things like e-commerce, it's absolutely vital that you stick to the same server for your entire visit.
So how do we make that stickiness happen? Well, one of the most common static methods is called IP hashing. The load balancer takes a piece of information that's unique to you, your IP address, and uses some math to consistently assign you to the exact same server every single time. Since your IP address doesn't change while you're browsing, you always land on the same machine. Problem solved.
And this is a fantastic example of the kind of trade-offs you have to think about. On one hand, IP hashing is amazing because it guarantees that session persistence we talked about, which you absolutely need for some apps. But on the other hand, it's not very adaptive. Just by pure chance, a whole bunch of users could get assigned to the same exact server, which could overload it while other servers are just sitting there with nothing to do.
All right, so we've covered the static rulebook. Now let's get into the smart stuff, the dynamic algorithms. Unlike their simpler cousins, these guys actually check the real-time status of the servers before they make any decisions.
A classic dynamic method is called least connections, and it's super intuitive. Our traffic cop, the load balancer, just takes a quick look at all the servers and sends the new requests to whichever one has the shortest line, the one that's handling the fewest active connections right at that moment. Now, this is awesome because it adapts to the workload in real time and stops any single server from getting totally swamped. But it's not perfect. It has one major blind spot. It only counts the number of connections. It doesn't realize that a server might have very few connections because it's old and slow and struggling to even process those.
And that brings us to the most sophisticated method we're going to talk about, least time. This really is the smartest cop on the block. It doesn't just look at the number of connections, it's also constantly measuring how quickly each server is responding. It then sends the traffic to the server that is both the least busy and the fastest. This is the top-tier logic you need if you're a huge e-commerce site or a major streaming service.
So after looking at all these different methods, let's just zoom back out and recap why this technology is so incredibly fundamental to the way the modern internet works.
When you put it all together, the benefits are just massive. Load balancers give us way better performance and speed. They give us high availability, so one server failing doesn't take down the whole ship. They make it super easy to scale by adding or removing servers. They make sure you're using your resources efficiently. And of course, they prevent those dreaded bottlenecks when you get a sudden rush of traffic.
You know, this quote really just nails it. The end game here is optimization. It's all about getting the absolute most out of the hardware you have and making sure your website is fast, reliable, and always on no matter what. In the end, that seamless experience we all have on the internet, it's really an illusion, right? It's carefully crafted by all these hidden systems like load balancers working tirelessly behind the scenes. It really makes you wonder what other invisible guardians and digital traffic cops are out there silently keeping our incredibly complex world in perfect balance. Something to chew on. Thanks for tuning in.